I've volunteered for several, I think two other webinars, and this is my third one. I'm sharing my screen now. Can everyone see? Is the Ubuntu TechHive website.
Yep, that's it.
Okay. So this is our website. We also have a Discord and a YouTube channel. Ben, Azizi, if you will, you can put the link in the chat. That way everybody will have access to those. So today, let me go into articles. We have our content already posted on the website. Today's webinar is about building agentic workflows using LangChain and LangGraph. So on the contents page, we have the English and French translations. The main agenda is to introduce what LLM agents are, and we're going to take some examples from simple to medium to advanced LLM agents, and then with that knowledge, we want to build a travel agency app where users can query, for example, if they want to travel from their source destination to their source city to a final destination. So probably if you live in Atlanta, you want to travel to Florida, and the app will, the agent will call some tools behind the scenes to produce the results to the user. So over here is a bit of text. You can take some time to review. Basically, this talks about the introduction to LLM agents. And then it goes forward to talk about the transformer. The transformer is an architecture that was introduced in 2017. With the research paper, the attention is all you need. Not sure whether we have a link here, but we can go to this site here, the axif.org. So here you can search for attention. Attention is all you need, and then pull up the paper here. I hope the font text is good. So actually we have a previous webinar about natural language processing that went into details about this paper. We talked about this architecture and how things work within the architecture. So LLMs were implemented using the transformer architecture. So you can spend some time and read this article. Going back here. And then we get into the agentic systems. Basically, yes, can
you increase the font just a little? I don't know if it's me, but maybe just a few. Yeah.
Okay. So this about.
Yeah, that's good. Yeah,
that's good.
Yeah, thank you.
So the test goes into agentic systems. Basically, there are vendors and implementers out there that are building these agents. And one notable of them is the LangChain. It's a framework where it allows developers to build applications using the LLM and external tools. All right, and then it goes into some examples of intelligent agents. And here is some applications of LLM agents in the customer service domain, content creation. You can use it in education and healthcare, as well as finance and travel and hospitality. For our capstone project today, we're going to take the example from the travel and hospitality domain. We went into the applications subdomain, and then it talks about LangChain and LangGraph. So I have the website for LangChain here. You can go into the documentation to learn a bit more about what LangChain is or what they do or offer. So LangChain is the core library that company built. And recently, because of agentic workflows, they've extended that library and created the LangGraph library. So LangGraph today is used to create the agentic workflows. And then lastly is the Microsoft Autogen Studio. We are not going to have time to get into the Autogen, but if you have time, you can do some research in that area. Any questions here? Okay.
Yeah, maybe I have a quick question. It was already possible to build agents with LangChain, right? So what's the need of having LangGraph?
So there was an introduction of the React pattern, which is another research paper that came out. So initially they built function calling using LangChain, and then the React pattern came along. So they rethink and re-engineered to build another tool instead of making changes to LangChain. They actually extended that to create LangGraph to model the graphs. Because the graphs, graphical representation gives you a lot of flexibility in designing your workflow. So they made a decision to build LangGraph in that aspect, but you can still create, you can still use LangChain to create agents and using function calling and all that. But the direction right now is using the graphical representation. That does answer your question?
Yes.
Okay. All right. So today's agenda, we're going to go into an overview of large language models, and then look at function calling or tool use, and then look into the React pattern. And then we will look at an agentic workflow using LangChain and Python. So exactly the question that Ben asked, you can build workflows using LangChain. However, there's an extension to build workflows using LangGraphs. So the goal is for us to understand the different components in LangGraph and how it's used to build applications. So once we understand the components of LangGraph, we will then work on the travel agency app and use LangGraph to build it. Okay, so first we have the basic model here. You can think of a model or an LLM as a black box where you send it a question or query, and then it produces an answer. So as mentioned, these LLMs are built on the transformer architecture. You can reference the PDF, the research paper that I showed earlier, and read more about it. Other than that, we can take a look. We can get into a demo with a simple app. I have to reboot my computer, so I don't have it set up yet, but it shouldn't take time. So our first example is a Q&A. You send a text to the LLM, and then it produces a response. I'll first go through the code, and then we'll go back and execute.
Yeah.
So,
is it possible to zoom in?
Zoom in, okay.
Yeah.
Let me know when it's good.
Yeah, no, good.
Okay. All right. Yeah, keep me honest because I'll do forget. So, so the first statement here is to install the libraries, the LangChain library. So these are the three main libraries to install. So you pip install that, and then once you install that, you import those library into your Python file or application. So this is an OpenAI class, an LLM chain, a prompt template, and this is for getting runtime, not runtime, but to get the keys, the environment variable keys into your application. All right, so this is where you can get your OpenAI key, and then to set up the prompt template. This prompt template takes the input variable, basically what the user is going to type in. And then the template itself is you are a helpful chat bot. Then you provide the input variable to the template. So this is going to resolve into the user's question. And then the chatbot will know to provide a response after this. So here is to instantiate the OpenAI class, and then use the LLM chain to chain the LLM. So these are the model here to chain the LLM with the template, and then the function here basically invokes the chain. When you invoke the chain, you pass in the user input, and then the user input is resolved in the template here. As you can see, it's the same name right here. That way, the LLM can have access to it through the template to provide a response. So this is where the user, gives the input and then calls that function, the chatbot response function, to pass the user input in, and then the results is printed. All right. Any questions before I start execution?
So maybe this is just me trying to understand, like, so chain, should I understand chain here a way to connect together like certain tasks in a, let's say, like an LLM project? Is that what, should I understand it that way? Or I guess
Yeah,
that's
the concept of a chain is like when you do Unix, you pipe one file to some right. So basically we pipe in the prompt. The prompt is this template here. We pipe in that into the LLM. So
okay.
you can chain different things in here. Basically, you pattern from one to the next, one to the next.
So the output of like one task, it becomes the input for the subsequent tasks, pretty
Yep,
much.
yep, that's correct. So here, the prompt will be the input to the LLM, and then the LLM will produce a response, an output.
Got it.
Yeah, so LangChain, this is how LangChain, they have different formats. There are other formats where you actually use the pipe symbol. So for example, instead of writing it this way, we can say prompt template, and then you pipe it into LLM,
Okay.
into probably the chat this way. And then you store it, you can store the response in a variable.
Okay.
So this way. So when you go on their website, they have I've used the pipe in the past, but recently I used the class.
Okay.
All right, any questions?
No,
you're good.
Okay, so
maybe I have a quick question. So the pipe, is it part of the LangChain library, or is it are they leveraging the built-in Python to do that?
I have not looked into the implementation of it, implementation of this library here, but I will not assume. I don't know the implementation, but I'm sure it's using some of the traditional way of piping things.
Okay.
All right. So there's an abstraction of typing, if you will. All right. So I've already installed the libraries, the LangChain libraries, and then this code I'm going to execute that, which we've already gone through it. So the code is good. And now we get into the input. So here you can ask any question. What is the capital Africa? And it tells you, Africa does not have a capital as it's a continent, blah, blah, blah. Right. And then you can get a response variable and pull values from there. So if you want it in a nice formatted where you can pull the value and then format it. So any questions here? This ends this demo. These programs will be on GitHub as well. So So we are done with the first program. I'm going to close it out. And then let's go. So we just looked at a simple question and answer LLM app. So the next level is the chatbot. So, they have some wrappers around the LLM. So when you think about it, as humans, we always chatting, right? There's a question, there's thinking, processing, and then providing an answer. So that's all we do every day. So these apps, these LLMs are being created to simulate, the human conversation. So that's why the chatbot came about. The questions here?
But are there any sort of drawback to or limitation to this kind of use cases where the LLM is trying to mimic, let's say, like a human conversation, but maybe some limitations? Like, are there limitations to this kind of use cases that you know of?
Not really. Limitations are introduced when building prompts, right?
Mm-hmm.
If you don't build your prompts well, then it's like garbage in, garbage out.
Mm-hmm.
Yeah, so that's why it's very important to get your prompt engineering on point.
Right.
And the data, if you're using RAG, your data has to be very good going in to get better outcome of it.
Yeah, I think the reason why I brought it up is because usually I've been on websites where they'll have a chatbot, and then you want to have the chatbot maybe solve a problem for you. Let's say it's Delta Airlines, for example, and you want to be rebooked, for a certain flight. What I've noticed is that depending on the company, like a company like Delta Airlines, for example, they may not let you do critical things, or they may not let the bot do critical things, right? So they may not let the bot, maybe change your flight without a human intervention to make sure that the bot actually did something correct. So yes, in terms of the prompt that you're talking about, the making sure that the prompts are correct, I think that's kind of where there may still be some ways to go. But if it's to answer like really simple questions, I think the chatbot definitely can do that.
Yeah, definitely. In such cases, it's probably a company policy, right? What functionality are they willing to expose to their customers?
Mm-hmm. Yep.
Yeah. So, and then there's security involved, data privacy, and all that.
Mm-hmm. Yep, absolutely.
All right. So next we get into function calling. Sometimes you're going to hear tool use. So basically what this is you still have your LLM, you have your, and it can be a RAG approach, right? Architecture. So basically users will send in queries, and in case of RAG architecture, those queries will be embedded, and then a similarity search will be made on the vector database. The result of that is the context that is appended to their user query. So the prompt template that we looked at, you have to define it in a particular way. You know, you have your query, and then you have the context appended from your vector store. So that combination, that prompt template is sent to the LLM, and then the LLM will review the query and then the context, and then determine what to do. So, for example, if the user wants to know the weather before they travel, the LLM will then define. The LLM will then call a function, and the functions can be n number of functions, right? So you can build different functions. These are, you can call them functions, procedures, methods. You know, we already know what they are. So you build those functions, and then for the implementation, you have to bind the functions to the LLM. Basically, you're telling the LLM what functions are available to use. So once the query comes in, it knows which query to call, and then produce an answer to the user. So in general, in function calling, this is what it means. Any questions here, or any comments, contributions?
So maybe more a clarification. So those tools, the functions. So I see that it has, for example, check weather, which I believe is a function that you created, right? And I see current time. So you can call any type of functions, basically.
Yes.
Okay.
But you have to. LangChain has a way of defining the functions. So far as you can give the functions the function name and description, and then your logic in the function, and then you tell the LLM what the function is. The LLM should be able to call that function. And this can be anything, like in any domain, any function.
Okay.
Yeah, I also have a question regarding that. So in the list of tools, there's the Python interpreter. Does this one present a risk? Like, for example, is it possible for someone to write a malicious prompt so that it generates some code that can be dangerous for the system where it's running?
I'm sure there is, right? But again, LLMs have some safeguards built into them. I haven't tested one with a malicious code, but I'm sure the LLM will come back and say, hey, they'll not be able to run this. But I'm sure there's a way to follow it.
Oh, okay.
All right. And as you can see, function calling are predictive, right? Basically, you have your set of tools or functions, and then you tell the LLM what they are. So in any case, the LLM has a set of tools to use. It's very predictive. It's very decorative and specific.
Also, like, just to be clear, it's not the LLM invoking the function, right? The LLM just passes the inputs to these functions.
That's correct.
Yeah.
So the inputs, the LLM will form the inputs based on the user's context question, and then sends the input to the family. I mean, some functions, not all functions have inputs, right? So if it does, it sends the inputs to it and then it executes. The function executes.
So you mean the function is an independent component. The function result we are passing to LLM.
That's
Am I
correct.
right? Okay.
That's correct.
Thank you. Thank you.
Mhm.
Thank you, Gary.
Right, I'll move on.
Kofi,
Yeah.
when you say you tell the LLM about the functions, could you go back to the code and show that, because I'm trying. Can you go back? Like,
We have not seen an example yet, but I'm going to show you in the next.
okay,
Yeah. We're going to see where the binding happens.
exactly. Yeah.
Okay. All right. So that was function calling, and then came the React pattern. The React pattern. See, I think it's called synergizing reasoning acting, something like that. There you go. So there's the research paper for the reasoning and action approach or pattern that models, these common new language models are using. So you can read through this. We're not going to do that here, but you can just read through this these examples here, and it's gonna make sense. Basically, the LLM goes through the thought. See, thought is the reasoning, is the thinking. Act is the action, and it's calling a function, and then the observation is the results from the function, and you can loop that way in order to. Here is looping, right? So thought one, thought two, thought three. So at the end of thought three, it finds the final answer, and it provides you with the answer. So basically, that's what.
So in the diagram, can you please open? So
Um,
in the PPT.
PPT. Okay.
Yeah. Just now. No, sorry, not PPT, sir. Sorry. The document, what is called PDF document.
Hold on.
Yeah. So in the left side, the arts part QA is our requirement. I mean, you're asking question, something to LLM. So it is automatically giving some answer, but plus, as you mentioned, reason, right? Something is adding the reasoning. Okay. That is you're saying.
Oh, sorry, I missed the question. So the user inputs this answer, this question.
Yes. Yeah.
Right. So
Yes.
what's your question then?
Yeah, this standard act only, these all are coming dynamically once the user is giving the question.
So the standard and act only is just telling you the standard way of searching
Okay.
produces the wrong results.
Okay.
And there are apps, there are LLMs like probably the previous ones also producing wrong results because it's using just action only.
Okay.
But when you combine the React pattern, which is thinking, acting and observing the results of your actions, it gives you the correct answer.
Okay. Thank you.
Yeah, when you think about it, that's what human beings, how we process things, right?
Yes. Yes.
If somebody asks a question, you think about a question, and then you frame your answer and you take action. Once you take the action, you can do all these things in memory, right?
Yes.
The action that you want to take, and probably think about what results that action is gonna produce before you speak it out. So this is mimicking how human beings respond to questions.
Thank you. Yeah, I'm good.
All right. Any more questions before I close this document?
Nothing in the chat. You're good.
Okay. All right. So with the PDF that we just looked at, this is all it's doing, right? You have the LLM. When you pass in the question, the LLM will do reasoning, thinking, thought, and then takes action on that thought. So when it takes the action, you also have, all these things are built in Python. So the environment is your Python. And then the results of the action is the observation. So the observation is then fed back into the LLM. And then the LLM will do another thinking. If the final answer is reached, then it's going to exit. If it doesn't, then it goes back to action and then loops that way until a final answer is produced. And as we're going to see shortly, this is a powerful pattern because the previous one, the function calling, you give it a set of functions, and then it's too rigid. But here you have leverage to do actions and looping and all that. In function calling, you don't get that, but in the React pattern, you can build your agents to loop and become more flexible in your app. Okay, so we have another demo. So the next demo is to create an agent or agentic workflow using LangChain and Python. All right, so here again, I'm going to go through the code and then we come back and execute. So there's building a simple React agent from scratch. As you can see, we are not using any LangChain framework here. All we need is the OpenAI LLM class. All right, this is for environment variable, which I don't think we're even using. Yes, we're not even using this. So here, so once you install the OpenAI library, you can then import a class. And this again is the Google Colab to get the OpenAI API key. So on this one here, we instantiate the OpenAI class. And then the next cell is to test whether the client is working, right? So in the client, we pass in the model, we're using GPT 3.5 Turbo, and then we pass in a message to it. In the message, we assign a role. Now, this is a user message and the contents. So here we're just testing to see whether the LLM is working. And then we get into building the agent class. So in the agent class, you define the init function, which takes the system message. I'm going to show you what the system message is. Probably let me show that now. So here's the system message. Is the prompt, right? The system message, you telling the LLM that it has to loop through some thought action and then do a pause. So when it pauses, that's where human intervention can go in, and then you do observation, and then at the end of the loop, you want it to provide an answer. So you telling the LLM specifically what to do, and this is basically you instructing the LLM to should I say mimic the React pattern, right? So use thoughts to describe your thoughts about the question you have been asked. Use action to run one of the actions available to you, which is with a tool. Then return pause. Observation will be the results of running those actions, which we've already described in the PPT. And in the prompt, you're saying that here are the available actions to the LLM, a function called calculate. So the calculate does some evaluation on some math. And then another function called average dog weight. This just determines the dog weight given, the dog breed. And then you give it an example, right? So the question is, how much does a bulldog weigh? And then the LLM will think and say, I should look the dog's weight using this tool, right? So you're giving it an example how to behave. And then after that, it has to take an action, which is calling the tool and passing the arguments or the input to the tool. And then once it finishes that step, it has to pause. And then you say you will be called again with this. And then the call will be observation. A bulldog weight is 51 pounds. And then the LLM will, because the observation is given back to the LLM will then give you an answer. A bulldog weighs this pounds. So let me go back. So that's the prompt. It's a big prompt. This prompt was actually created by LangChain's, the LangChain group. Yeah. So as I was saying, to create an agent, you first define the init function, which takes the system prompt, which we just looked at. So you store that as an attribute in the class, and the message that this attribute here, the messages just saves all the messages that's going on. the app. So if there is a system message, basically if there's a prompt, the system prompt here, then append that message append that prompt message into the message dictionary here. Not dictionary, but list, right? So it's basically appending to that. And now, once it does that, once you are done with that, you also have to create the call function. Basically, when you call the agent, what should happen, right? So when you instantiate the agent and you call it and pass it with a message, what should happen? So this is what is going to happen. There's the first line here is just doing the appending a user message into the message list, and then it calls an execute. So execute is another procedure that really calls creates the LLM, right? So here you can see GPT-4 or the temperature, and then you passing in the message that the other functions have been building, and then it returns a result, right? So you've called the LLM, you've passed a message into it, and then the results will be received in here. All right. So that's what the agent is. Any questions here before I keep going?
Yes, I have a question. Maybe is it possible to clarify because I see the messages have roles, and then I see role system, role user, and role assistant. Like, why is there a need for such differentiation?
Yeah, so the role system, you instructing the LLM what to do, and that is this prompt, right? We're telling the LLM to go through this workflow. We giving it the function names. We're giving it some examples, basically how the LLM should behave. So that's what this message contains, this line contains, the role system. Now the role user is the you the user using the application. So whatever you type in, that question or query is being appended to the same message list. And then once the LLM responds with an answer, for example, in this case, it returned the results here. Yeah. It's also adding the results, appending the results to the same message variable. And since the message variable is passed to the LLM, it has a history of the roles that are defined. And based on that, it's able to provide the right results.
Okay.
Is it clearer?
Yeah. So in a way, it's I mean, that differentiation is useful for both the user as well as the LLM for how it's processing the different text inputs.
Yep.
And also the way it keeps track of the context.
Right.
So, okay, thanks.
Okay. So down here, you then define your tools, right? The calculate tool and then the average dog weight tool. This is just some simple functions, but you can go as complex as you want. The main thing is the returning of the the messages from the functions. So once you define your tools, you then put it in a dictionary, right? So they calculate, because this web calculate an average and dog weight, as you can see, it's already defined in the prompt template here. Right, so everything is so you define you list the tools or functions in here, and you provide a variable. So this is a call to, not a call, but it's just pointing to where this function is. The same thing here. So you have your list of tools, and now you create your agent using the prompts that we went through above. Now you have the agent. The A-bot is an agent now, and now you can pass in questions. So you pass in questions, you get the results. So that's what all this is doing. And then this one is a complex question. I have 2 dogs. So this time it's not one, but they have 2 dogs, a border collie and a Scottish terrier. What is their combined weight? So the LLM. So this section is actually manually. We're going to go through this and execute this manual, and then at the end of it, we build a loop to do the manual work that we went through here. So this loop is actually doing the same thing as the cells above here. I'm conscious of time, so I'm moving faster. And then you can input question and then get the results. All right.
Ben, do you have a question?
Yes, I have a question. I have a question regarding the calculate function.
Okay. Calculate function. Yeah.
So I see that it's using eval and returning the result. So the what, if I understand well, is some Python is the text representation of some Python code that can be evaluated. Is that correct?
That is correct.
Okay. So that text, is it coming from the or
so
that LLM generated?
the LLM will generate and send the inputs to calculate.
Okay, so the LLM will generate its code. Okay.
Yeah. So the LLM generates what and then name, and then calls the tools, the functions.
Okay. So in that case, is this one similar to the Python eval tool, like from LangChain? Is it pretty much what it's doing?
I'm not sure. Did you say Python and LangChain eval tool?
Yeah, I thought I saw one when you were showing the code.
The code down?
No, like earlier in some previous. It's probably the. I forgot, but I think I saw it earlier when you were showing.
Maybe in the prompt then, because I know it mentions. Yeah, we saw eval somewhere, but
Yeah, like earlier when I was asking I think it's earlier when I was asking the question regarding the safety of evaluating code.
Mm-hmm. Oh, on the PowerPoint.
Yeah, that's probably the PowerPoint.
Yeah. Okay.
Mm.
All right.
No, but that's fine. I was just I just noticed that because that that's kind of related to my previous question regarding the safety, because what I saw here is that there's no guard pretty much. It just evaluates whatever comes.
Right.
So hopefully the code that comes is safe to eval.
Yeah. So that's why, when you're coding these things, you have to really do error checking and all that. So this is not production ready, as you know. So you can review using Python code to review the output of the LLM strings, the statements, and then you build in logic to make to make sure that there's no malicious code going into your function.
Yep, thank you.
Yeah. Oh, sorry. So I executed I installed the OpenAI and then executed the imports and then instantiated here. Now we test the LLM and see the results. Hello, how can I help? And then we get to the creating of the agent class. So the class has been created, and then we build our prompt. If I'm going too fast, you'll let me know. I feel we've gone through this already. So, so we have our prompt now, and now we define our tool set, the functions. So we have the tools here. We have the calculate and the average dog weight. So on this agent prompt, this is where we instantiate the agent, and then we send the prompt in. So now we have an agent. A bot is an agent, and then we send it a question. How much does a toy poodle weigh? And then that should produce an answer. So this is the results from the LLM saying that I should look up the average weight of a toy poodle using the average dog weight action. So it knows, based on the question, it knows to use the function because we had two functions, the calculate and average dog weight. But in this case, based on the question, it knows to use the average dog weight. And then the next step is to action on it. So the action is to call the function and then pass the toy poodle as a string or as an argument to the function. And then in the prompt template, we asked it to stop or pause after that. So that's what is happening here. So once.
Excuse me, is that me or this screen is frozen? I'm seeing something different from what you're explaining right now.
Okay.
Oh, yeah, I thought it was me.
Is it frozen for everybody?
Well, I thought it was only me. I even tried to rejoin, but I'm seeing the simple React agent from scratch, the beginning of the code.
Yeah, same thing for me also.
Oh, okay.
All right. I don't know. Let me refresh and see.
Yeah, it's the same thing for me too.
Maybe you're showing a different screen.
No, I can't. Well, let me.
Stop and start.
Yeah, let me stop and start again. See. Stop presenting. me see.
Yeah, now good. Yeah.
Okay. So I'm not sure where it froze, but should we go back from the top?
Yes, please.
All right. So yeah, so basically here I install the OpenAI library. And then we import the class. Then we instantiate the class here. And then here I was saying that we testing the clients, right? The object here is the OpenAI LLM object here is the client. So we instantiate. We passing a message to it to make sure that it works. And we're using the GPT 3.5 table. So the result of that is, hello, can I assist you today? So far, so good. We get to the agent class, we create a class, and then we set our prompt. All right, so we've seen all this. And then the next thing is to build our tools, our functions. So in this case, we have two tools. And then the known actions is the tools, the list of tools we have. And then we instantiate the agent. So a bot is now an agent. And we send a message to the agent. The message is, how much does a toy poodle weighs? And the results is going through the thinking, the action, and the pause process we stated in the prompt. So it's saying that it knows that the question is asking for toy poodle and how much it weighs. So it knows which tool to call. So in the action, it's going to call the tool and then pass the question, the variable, into the tool, the argument. And then we told it to pause after the action. And that's what's happening. So here, make sure, yeah. So the next line is where, so we're doing this manually, but you can automate this. So the next line is where we told the LLM to stop, so it stopped. So that way we can do it manually. So the toy poodle here, we're going to pass it to the function and then get a result. The result is that the toy poodles weigh on average 7 pounds. And then we manually doing the observation. Basically, we pull in this text from the results, and then label it as observation. So this is how the observation looks like, and then the observation. After the observation is sent, so this answer is sent back to the LLM. No. So here the LLM, after the observation, we call in the agents, right? So the agent is outputting the answer that the toy poodle is 7 pounds. Now, when we look at the messages, we went through the code. The messages is building the roles, the system, the user, and then the assistant. And it's doing a pause and going through the observation and providing an answer. So this gives you a part of what steps is happening based on what you instructed it to do. So we go back and then refresh the agent, okay? And then we asking the agent a complex question now. we have two dogs, the Border Collie and Scottish Terrier. What is their combined weight? So when you execute that, when you call the agent and you send that question in, it goes through the thinking again. I need to find the average weight of both a Border Collie and a Scottish Terrier, then add them together to get the combined weight. And then the action is to call the average dog weight and pass in the Border Collie and pause. So it's doing one thing after at a time. So, but I mean, as I said, we're doing this manually before we get into the looping aspect. So that's what it's doing. So manually, we're passing the Border Collie in there. So the LLM comes back. The function goes through its logic and then produces this results that a Border Collie average weight is 37 pounds. And now we go back and say next prompt. So this is the next action within for the LLM to do. So the next action the LLM says, now I need to find the average weight of Scottish Terrier. So this is the second dog, and it says the action is to call the average dog weight and then send the argument in, and then pause. So that's what is happening. And then now we execute the function again. And then the results for the Scottish Terrier, the average is 20 pounds. And now we're going back to refresh, or do a next, sorry. So when we do a next, now the LLM is saying that it's found the information, and now it's going to calculate the sum of 37 and 20, and then pause. So we're taking this 37 and 20 and passing it into an eval function to calculate the basically to get your observation. And then the next thing will be the answer from the LLM. So we've gone through all this manual stuff, and now we want to automate that. So this is what these two cells are doing. Basically, there's some regular expressions to find the action within the results of the LLM. So the action here, and then this function here is doing all that we went through manually. And then we pass in a question, we form a question, and then we call that function, that loop function. So now it's going to do that as it streams. So as you can see, it's going through the same thing we did manually automatically this time and coming up with the answer, 57. Any questions? Okay. Am I audible?
Yeah, we can hear you.
Okay.
Yeah, no questions.
Yeah, so I'm moving a bit fast, so because it looks like we have more to cover. All right, so let me go back here. Open our PowerPoint. So this is what we just did, the demo. The next one here is to build a agentic workflow using LangGraph. To implement the graph concept in LangGraph, you need three main things. It's more than three, but three main things. You have to define your nodes. The nodes can be anything. It can be an LLM. The nodes can be a document, an entity, a word, an action, anything you can think of, you can define as a node. Because graphs are built with nodes, right? From one node, you jump to the next node. So you have to know what nodes you need in your app. So once that is defined, there's something called edges. The edges connect the nodes together. So you have the parent node and then the child nodes, and then you have the edges in between connecting the parent to the children. And within that structure, you can also build in conditional edges. Basically, if you want to make some decisions based on some output, right? Whether you should execute the left branch or the right branch. So that's what the condition edges is. And this is an example of a LangGraph. Basically, you have a starting point where you feed in questions to the LLM. And then in this case, it's a simple two-step one, but it can be complicated. I mean, graphs, you can build any graph you want, but this is a simple one. So basically here you have the LLM, and then the LLM does some reasoning, the thinking aspect, and then your code will do the action. The action is basically calling the function, for example, the average dog function or the calculate function, and then the results you send it back to the LLM. LLM will do another reasoning, and then if it has to do a second task, then it goes back into action to complete that task, and that result is sent back to the LLM. The similar example we saw in the previous demo. And then once there are no more actions to take, then you end the process. All right, so let's get into a demo here.
This is a question.
Yes, go ahead.
Yes, okay. So in your previous graph, the graph that you were just showing, how are the nodes, edges, and conditional edges represented in the picture?
Hold on.
Yeah, so based on the definition you gave of nodes, edges, and conditional edges, like how are they depicted here?
Here, okay, so here the yellow, the yellows are nodes. So for example, the OpenAI, the model, the model, the LLM is a node. And then, as I mentioned, a node can be anything, right? So you can create a node for actions also. Basically, that is where you call your functions. And then in this picture, it looks like the LLM has some conditional edge built into it because it's doing true and false here. So the nodes are the yellow circles, and then the edges are the arrows going from one node to the next. For example, from action back to the LLM is an edge. We'll see a better picture from the program.
Yeah, okay.
Right. So we have 30 minutes. I'm trying to get into the travel app. So okay. All right. So here I'm going to move a bit fast because it's the same concept as we saw in the previous one, but just using a LangChain and LangGraph. Right. As you can see, we have the libraries here, the LangChain, LangGraph, and OpenAI. This install here, the next install here is where the libraries that helps in creating the picture, basically drawing the picture for us. And then we import some OpenAI and Tavili API keys. Tavili is a search tool that does a Google search or maybe a search on the internet. And then here we are importing what we need for this app. So we import in LangGraph. When you import LangGraph, you have to, the two main classes are the state graph and then the end. You'll see how that is used. And this is Python type dict. And then we have the messages here. We have the system message, human, and tool messages. We have the OpenAI chat OpenAI class, and then the Tavili search results tool. So here is just instantiating the Tavili our search tool, and defining it to look for to bring four results basically. So we'll see how that is done. The agent state class here, this is very important. This is defining the messages and the type of messages. In our case here, this is a list message, and then there's a function built into this, annotated command. Basically, when you add a message, it's not overriding the contents of the messages, of the messages. Rather, is appending to it. All right, so that's what this class is useful for. And then you create your agent. So as we saw earlier, this is our init function or method. The init method is taking the model. The model is the LLM, the tools. We're going to define several tools, and then the system message, which is basically a prompt that you're going to pass to initiating the agent. Right. So in here, you take that system prompt, and then you store that attribute. And then this line here is what creates the graph, the state graph, and then passing it the agent state, which is the messages class. So when you do that, the messages is now available to any part of the node. So when you traverse the node, in any parts of the node, you have access to the messages. We tried to do that, building the messages manually in the previous two demo, but this time, when you do this definition, and when you define it this way, it becomes automatic and available anywhere. Basically, it's local to the graph that you created. So this is our graph, and within our graph, as we mentioned on the PPT, the first thing you need to create are the nodes. So you have to define what nodes that you need in your app. So in this case, we need an LLM. So this is the label. This label is the LLM, And the function that is going to call is the call OpenAI function, which is defined here, right? So that's our first node. Our second node is the action. So the function call and everything happens in the action step. So that node is called action, and the function that is called is take action. And take action is defined here. Basically, take action is taking, it's looking at the tools, the state, sorry. The state is basically the message variable. It takes the message variable, and then because the messages are being appended to the role, the system message, the user message, and then other messages that you define, they are all appended to the state. Because I mentioned that the message is available anywhere. So in this state right now, you can pull the tools that are defined, that you have listed in that message. So you take that tools and then you loop over the tools. So you loop over the tools to see whether, so this is where, when you loop over the second branch here, this is where the tool is being invoked, right? So this is where you're going to invoke the tools, and then the argument here is coming from it's coming from the message. Yeah. We can, when I execute this, there's some print statements we can really see what's going on. But basically, this is where you invoke the tools. And then after that, you have to append. This is the results. You have to append the results back to the message. So I go back here. So that was take action. Yeah. So in the PPT, I also mentioned that you have to create a conditional edge. So conditional edge, basically, you have to define the conditional edge takes input. So you have to define which node is sending that input. In our design here is the LLM that will be sending the input to this node edge. Sorry. Once it gets that, it has to call this function here, whether it exists. So what this function, the only thing it's doing is checking the tools to see whether, that the results, which is the function, because the LLM is outputting the tools, right? So this function is to check whether the tool exists. So if the tool exists in the message, then it sends if the tool exists, then it's true. So it calls the action node. If it's false, then it ends the loop. The other edges you have to define.
By the way, Kofi, I think your screen is froze again.
Oh, I don't know why. I'm sure that's my internet here. Let me know if it's back.
Yep, looks good.
All right. Yeah, so basically we're creating the graph, we adding nodes to the graph, and then we adding conditions, and then you have to define the edges, right? So from the action node, we go to the, we give the results back to the LLM. And then you also have to define the entry point, but you have so many nodes on your graph. Where is your entry point? So in this case, our entry point is the LLM. So basically, when you send your question in the graph goes to the LLM. So this build, this thing here, or this code here, builds your graph, the structure, and then you have to compile it. So once you compile it, you have the graph, and then you have your tools. The next line is to get all your tools, or you have the tools defined up there. And then this is where you bind it. I think there was a question from Ben, was it you? How the tools, how the LLM can know which tools to use. So this is where you do the binding. So you bind this to the LLM, to the model. So this is how LangGraph, this is how you create an agent in LangGraph. As you can see, you can build a whole bunch of nodes and edges and make your graph complex.
Hey. Hello, good day, Coffee.
Yes.
Can you hear me, or is my broken up? How's my voice sound?
I can hear you, Claire.
Okay. It's kind of related to this topic, but it's a bigger context. Can I ask the question, or do you want me to save it for later?
No, go ahead if it's related. Yeah.
Okay. So let's say I've been looking at a lot of flows in different tools. And let's say that you have an LLM, right? And then you have a tool, and then that tool goes to another LLM, right? So the tool is like a node, node B, LLM1 is node A, and of course there's a tool in between that connects the two LLM. Anyway, let me get to the meat of the question. If you you know how the LLM, you can have prompts and on the LLM that evaluates the results, right? So do you know of a tool or a service that evaluates the results that picks, so initial results may pick tool 1, but in reality, if evaluates results for the quality and so you got better results, you don't want tool 1 anymore. Maybe you need to pick tool 2 or no tools at all, because the evaluation of the prompt improved the quality of the output. So there's no longer a need for you get what I'm saying? Like, do you know of a service or some kind of open source projects that is doing something like that?
You have to build it. Let me see. What you're describing is something like this. It's something I wanted to cover, but I'm not sure whether we'll get the time.
Mm-hmm.
So there's an example of writing an essay, like in college when you are giving an essay. So here you have your notes structure built. The planner here is an LLM. That's the outline based on the topic. So it has a list of topics, and then there's another LLM that so it can be the same LLM, or you can use a different LLM here to do the research on those topics. Now you have the list, your outline, you have research on those outlines, and then you have another LLM generating the text of those topics. I mean, the outline, and then based on your research. And then you can send that information, that whatever draft is generated, you can send that to another LLM, totally different, to reflect on the draft, basically to critique the draft, and then send the results of the critique back to the generator. And this can keep going until maybe there's, based on your logic, if the output is good, then you exit. So it's kind of what you asking. Am I wrong or correct?
Yeah, sort of. I mean, that does accomplish it. I sort of asking that, so that was a good example. But I was thinking, like, depending on the results and the quality of the results, you're feeding other LLMs or scoring the results, providing feedback, improving the results, whatever, technique that's being used. So now you have results, but then normally, part of your logic or your flow, you have tools, right? And then the next step is, to go to the tool. But then I was thinking, like, hey, well, maybe I don't need that tool. Maybe I need a different tool because of the results that I have not. So it's almost like a dynamic choice of tools or no tools, depending on how, because the tools play a role in it, but at the same time, when are they needed and when are they not needed, kind of workflow, So.
Yeah. So you have to define the tool A, B, or C. They all do something slightly different to produce the right results that you wanted, right?
Right.
So you still have to define the tools, the functions. So the LLM needs to know all the tools that is in the app to generate, a graded response that best meets your needs. So
Okay.
I don't think there's some work out there. You actually have to think through it and build an agent to do that.
Okay. Thank you.
Sure. So it's good you brought, you asked that question, because I wasn't going to show this, but
Yeah, your screen is frozen, so I don't see what you see. I don't know about the rest of you, but I don't see it.
Yeah,
Yeah, it's frozen.
I didn't see it either. So
oh,
I thought you were just describing. I didn't know you were showing something.
oh, sorry, no. I have to move to Zoom or something. Sure.
Anthony, I kind of have a follow-up question to what you just mentioned. Is it like, so based on what you said and what you're looking for, right? It's something like this, that something like this work. So you have a tool that, like, let's say, calls two functions, and then they both return something, and then the tool evaluates both functions, the result from both, and then after comparing both, it can define now that, okay, you know what, based on the result, which is 90% close to what both of them are returning, then I don't need to move forward. Otherwise, that means the result is not complete. Because I don't think you can accomplish that with just one function. It looks like you have to call multiple and compare.
Okay, thank you for sharing. Yeah.
Can you all see my screen now?
I see it. Yep.
Yeah, so that's what I was describing. So all the yellow, the 5 yellow stuff, they are all nodes. So you have a research paper. The planner is an LLM that does the planning. And then it creates an outline. The outline is given to an LLM that does the research. Basically, it can be any RAG kind of research. Comes up with the results and send the results to an LLM to do the generation. So the generation happens, and then you have a reflection and then a critique. You can critique the draft and send that critic back to the generator to regenerate. Or you can give it to another LLM to do the regeneration. So it's the way you come up with your architecture. You can build complex flows here. Does this help?
Yes, thank you.
Okay. I think it's my PowerPoint. When I switch over, then probably I get frozen.
Yeah, actually, I also wanted to jump in, Anthony, if you, actually, I can quickly show you. Sorry, 1 second. I'm just gonna.
You want to share a screen? Or?
Yes, just 1 minute, just to show the.
Okay.
Okay. Is my screen visible?
Yeah.
Yeah. So Anthony, you can also look into the instructor library. It's another way to interact with LLMs, and they have a feature called parallel function calling, right? And they have a code example here that can perform both a Google search and weather search at the same time. And then the result of the function calls is here, right? So potentially you could play with this and see how you can tweak your prompt, so that the two tools pretty much can compete on the results. And then once you get the evaluation from the LLM, you can decide. So that's one option. That's it.
Right. The competing, and then also you got the suggester editor. There's different ways. Yep.
So the link is in the chat.
Okay, thank you.
All right, I'm going back to sharing. Let me know if you can see my code.
Yeah, we can see.
Yes.
All right, so I believe, we went through the agents. So we have an agent created now. We know what the prompt template is. So we pass in the model. So we instantiating the agent here. We pass in the model GPT-3.5, and then the tool, and then the system prompt, which is over here. So we pass that through in, and then the image here is the function that draws the graph that we see with the nodes and connections edges. These are messages being passed to the agent. Basically, you're asking it what is the weather in San Francisco. Then you invoking. So you're passing the messages to the what's it called, to the graph, to the agent, and then the results comes back, and then you can go back and ask more complex questions. All right, so as time is flying, let me go and execute this quick. Let me know as soon as I freeze on you guys. Excuse me. So here we're importing the libraries, the LangChain LangGraph. Come on. All right. So now we're installing these are libraries to do the drawing of the graph. Sorry about the scrolling. Okay, that's done. Now we get keys to the I feel like we've seen this code. It's 3, right? So we're importing the libraries now. This is the tabulated search results. So we have our tool. This is where we define the message, and then we define the agents, and then our tools, functions. Then we create a prompt and send it to the agent. So the model tool and then the system prompt. And then the graph will look like that. It's a similar graph. I took that picture from here. Then we go in and ask the agent what the weather is in San Francisco. And these are the values in the dictionary that's returning. And as you see, say back to the model. So it took the action and it went back to the LLM, to this node, which we defined in the code to do. So this is the results. So the tabulated search results library or tool, this is what it did. It went into on the internet and pulled all these information back to the, to the so content. We can grab the content from the message. So it tells the temperature of the in San Francisco. So in this step, we're asking for the same question but in 2 different cities, and that's what is going. It's looping through San Francisco and LA, right? And it's going back to the LLM. Now we can pull the content from there. And then lastly, we're passing in this question: who won the Super Bowl in 2024? Typically, LLMs will not give you the answer, right? But we have the tabulated tool to go out on the internet to search, and it provides the answer. Charlie, he gave 2 answers: Super Bowl and Video of California. However. So that's the end of it. Any questions? All right, I'm going to close out of this. I really want to demo our travel agent. Let me open the agent, the travel agency app. Let me take a minute. Let's take a minute and go through these points. So basically, we're trying to create a travel agency app. Normally, what you think about is the tools. So what are the different functions that you need in your app? So here we have the booking of tickets, booking of hotel rooms, and local events to give you some recommendation in your destination. As far as LangGraph, as we've seen, you have to create nodes, you have to create action nodes, you have to create your edges, you have to compile the code, you have to invoke the graph, and you can draw the graph if you want. With the core LangChain, basically you have to write code to instantiate your model, and if you want to be complex enough, you can add RAG approach. You can build your app on a RAG approach, right? But that's not what we're doing here. So that's it. So I'm going to go into the code where we can review. This time I'm going to execute as I go and explain as I go. We have 5 minutes. Excuse me. Is my screen frozen? Are we good?
We're good.
Okay.
Good.
So here, pip installing all the libraries I need. I'm using SERP API, which is a Google tool that gives us the data for hotel, flights, events, and others. But we're only using those three. We have the graph library. So this is still installing. As it's installing, let me import my programs. The event, hotel. I made a flight.
Can you
So,
elaborate on that? You importing your programs. What programs are you talking about?
come again?
The programs that you're importing. What do you mean by import your programs?
Okay, so these are the tools I built. So this event handler is a Python code.
Yeah, technically the high level view. So like event handler, does it handle just the events on the application events, or does it like handle like booking and all that?
Yeah, so events only gives you it's like a recommendation system that pulls in your destination. For example, if you're traveling from Atlanta to North Carolina, when you get to North Carolina, what are the events in the city, right? So you have some clubs, you have restaurants, you have, music, musical events. It gives you that list. The flight is similar. The flight gives you a listing of the flights based on your query. Hotel also gives you all the hotels in your city, in the destination city, according to your query. So these are the tools that I'm going to bind with the LLM. That way the LLM knows to call these tools. So similar concept to what we've seen in the previous demos, but this is more structured. All right, so that said, the installation is done. So here, the next cell, I'm mounting my drive. That way, I can have access to those programs, those tools. So this is being mounted now. The mounting was good. So in the code here, basically, I'm getting the current directory to where to find the flight handler, the tool. So that's all I'm doing here. So that's good. The tool exists. That's what it's saying here. I'm going to do something similar for the hotel. So we have our hotel Python model, and then the last one is the events, right? So the three files exist now. Now I'm going to import the files into my Python, into my code. So the hotel flights event. So I'm importing those programs. And then these are LangChain, LangGraph, libraries that we've seen earlier. So I'm going to execute that. So that's good. I'm going to get my PinAI API key. That's good. And then I'm going to instantiate my tools. So we have the flight tool, the hotel, and the event tools. So these are my tools. The agent state we've seen in the previous demo. Basically, you're defining your message variable. That way you can keep track of all the system messages and user messages. And then you build your travel agent class, which is the agent. It's similar to what we the previous demo, right? So this init method is you're taking in the model, the LLM, the tools, and then the system prompt. And then you create your graph. You create your graph here and pass in the message class. So now you have your graph, and then you add the nodes. So similar to what we've seen, the LLM will call the OpenAI action, would do the action, and these are the conditional nodes. So similar code, right? Nothing changed. We're going to bind. We're going to compile. We add the edges. We set the entry point as the LLM node. We compile, and then we get the tools and we bind. We bind the tools to the LLM, to the model. So now that we have that, we're seeing all this code. Before is the same code, right? But I'm not executing. Okay, so let me execute. So this is our travel agent. First, we started from simple to medium to a bit advanced, and we're using the same advanced to create our app. So here is the parameters to our flight tool. So basically, we're going from Atlanta to JFK on these dates. And I want the currency to be USD. So I executed that. Here, we're setting our prompt, we're setting our model. As usual, we're listing our tools, the flight, hotel, event tools in a variable here. And then we instantiating our agent, which takes the model, the tool, and the prompt. And then we're going to draw we're going to draw the graph. So this is it. Again, is the same thing, we've seen. And now let's get into using the tool, using the agent. So here we have a message that we need to travel to New York. So that's the message. That's the initial message. And then we pass in the parameter. And then based on that, this will serve as an input to invoking the agent, right? So we invoke that, and what we get back is the function calling, based on the query parameters. We're going from Atlanta to New York, I said. So it knows to call the flights tool. And then it goes back to the model with this result here. And to view the results, we can list it in a human readable form. So basically, you have Delta Airlines for $399 with a duration of 6 minutes. We have American Airlines, we have JetBlue, and all that. And then it's asking which option would you like to choose, or would you like to explore more details about any specific flight? All right, so I haven't built a loop in here, so we are not able to loop, but you get the idea. So similarly, we go back and set a message, human message for to get a hotel information. So there's a list of the parameters for the hotel tool. It takes the city and then the duration, and then the currency. Again, you form your inputs, and then you call the agent. We are almost done. Again, it does a function calling. This time it's calling the hotels tool, and then it returns a result. And the result, what format is this? So these are all hotels in New York. All right. And then we do something similar for the destination, the events, right? So basically you saying that you're telling the LLM, could you recommend some events in my destination? And then you're passing in New York City, and then the language and currency, I think. Yeah. Language and country. You form that input and you execute. Promise you this is the end of it. So that, then we can view the events. Hold on. We can view the events. So these are all the list of events going on right now in New York City. And this ends the presentation. We skipped one, the essay writer, but we did mention it and show the graph, so it didn't do too bad. Any questions, comments?
Maybe I missed this. What API are you using to get this information? The live events and the hotels and all that?
Yeah, the same question, right?
SERP API?
SERP?
Yeah, SERP.
Okay.
Yeah, when you, forgive me for scrolling. We did import. Where's that? It's in the tools.
Maybe at the top.
Yeah, we did install SERP. Yeah.
Okay.
Yeah.
All right. Thank you. SERP API.
It's got many more. You can do maps. You can do a whole bunch. Like, it's pretty good.
So one question here, the annotated type, right? You mentioned in the first one. What is that one?
It's a way in Python to define any type. You know, you have types like float and int, but you can define your own type. So
It's like equivalent to data type, any data type, any?
yeah, yes, but but you define that. Where is that?
I think somewhere is yeah, here you might be seeing.
Yeah,
Yeah,
right.
this one, yeah.
Yeah, so basically here you defining it. I think you should read on this library in Python. Basically, you know, it's a simple type name is at runtime it's equivalent to a plain dictionary. You can read on, you know, read on some documentation on it. Basically, you can define your own type. So in this case, we are using list and any message here, and then the add operator here. You can do add operation. Basically, you append into the message. So in all cases, and it shouldn't, the agent states, you can have different attributes. So for example, you can in our case we're doing hotel, right? So you can say current, you can spell current hotel, and you can say string, right? So you can have multiple attributes here, but the one that says annotated, that's, so for example, this state when you set this state, you override in the value, but for the annotated one, it appends. You cannot override it.
Got it. Okay.
Yeah.
Yeah. So here we have a three tools is there: flight tools, hotel tools, and event tools. Example, in the flight tools, we got an error. I mean, the flight API is having some issue. So in that case, how we can send some message to user? I mean, in technically our agent is not working due to some flight issue. We want a hotel or event tool. Right? How we can stop or how we can give update to the user?
Yeah, so you're talking about error handling. So you can do error handling in the flight tool itself. I think I have it in the VS Code. So there's our flight tool, right?
Yeah.
So as you see, I'm doing error handling here.
Okay. I mean,
Yes.
you're talking about the regular Python error handling only. We can solve this one.
Yes.
But assume like the flight tool, we are trying to do some flights from New York to something like a Buffalo. The flight's information is not there, right? Technically, we won't get any details in that scenario. I mean, this is technical related error code. Think like a functional error code. That the flight information is not there in the respective date. Something floods or some reason, the flights are cancelled in that scenario.
So if the flight information is not there,
Yes.
oh, like the results is blank.
Yes, sir. You're right.
Oh.
You're right. Yeah.
Yeah, the LLM. I believe the LLM. I mean, we can not try that now, but we can make that. You can test that, right? In testing, you can make your results blank and see what the LLM will do. You can add that to your prompt also, that if the results is blank, it should give, a human readable message or something.
Okay.
Yeah, so you can build error handling in the tool itself and also do some prompt engineering also.
Okay.
Yep. Any questions, comments?
Thank you very much. Really nice presentation.
So, any comments from anyone?
Thank you for your presentation.
Yeah, thanks, Kofi.
Welcome.
Yeah.
All right. So if nothing else, get a share back to Ben or Aziz.
Yeah, thank you, Kofi. I've learned a lot.
Yeah. I think all the links that have been shared in the chat. So if you want to go back and take a look at the talk, yeah, it's possible. And eventually, this was also recorded, so it'll also be posted.
Yes. As soon as that will be posted.
All right. So the next meetup would be in 2 weeks, and I will let you know what the subject is, and we'll go from there.
Yeah, actually, we had a discussion with Kofi to maybe build a UI on top of some of the projects that he implemented. So I mean, I don't know. You guys can tell me what you think. Maybe we could do a part 2, and then try to leverage some of the work that Kofi did and build more like a visual demo for that.
Yeah, I think that's a good idea because some of the users here are not. I know this session was code heavy.
Yes.
Yeah.
Right.
Yeah. Yeah, but I find the LangGraph library to be pretty neat. Especially last night, I mean, I dug deeper into it by watching some videos, going through some Jupyter notebooks. It's very, very neat. So
Yeah, it's well structured. It's modular.
right.
It can be simple. It can be complex.
Yes, because what I noticed right away from like with LangGraph compared to some code we went through over like the previous presentations was that when it's time to put together the tools into a workflow that makes sense so that it can do the processing and produce the results we expect. It's very ad hoc the way it's done manually. Whereas in this case, they found a way to address the plumbing between the different parts so that the data can flow easily. Whereas when it's done manually, it's not obvious how to do it in a consistent manner.
Mm-hmm.
You know, one node might accept a certain type of data with a certain signature, and then the other node might accept a different one. You know, so at each step, we have to manually do the transformation. Whereas here it's very neat.
Yeah, here they use the message object and made it locally available to all the nodes. So you can always know the state of the message.
Right.
And we didn't get deep enough because you can do parallel agents also with this. And they have that as well.
Yeah, and I also noticed, I mean, by looking at the code briefly on GitHub, it looks like for some parts they are leveraging Pydantic behind the scenes. You know,
Yes.
so when a tool has like two inputs, like let's say the first one is a string, the second one is a float. Behind the scenes, they grab these inputs and turn them into a Pydantic object so that they can serialize it and do validations and stuff like that. So.
Yeah, it's interesting. They're doing a great job.
Yeah, I didn't like very much the old LangChain, but this one I can see myself using it. Any other comments?
Just a suggestion. Maybe we should do a topic on innovations with transformers.
Innovation with transformers. Okay, like what aspects of it? Maybe can you elaborate a bit?
Just somebody's latest findings, you know, whatever they learn in the next couple of weeks or a month.
Okay. Yeah. Anyone wants to volunteer, or would you like to volunteer for presenting that?
Yeah, Hafiz will present. He's going to build on top of what we did.
Not now. I'm barely making it now. I don't have any time. But I will definitely do it after
You got voluntold, Hafiz.
Yeah, after August 15th, I should have some time to, present.
Okay.
After August 15th?
Yep.
Oh, we need to talk about that because I think towards the end of August, I forgot the exact date. We may have a talk in the pipeline from another member. I think he wants to present about like graph databases and stuff like that, and maybe throw some LLM in the middle, maybe.
Yeah.
Yep.
Then, yeah. So we'll coordinate for sure. But currently, the next one is the 10th. So that one is open. There's no topic yet for the 10th.
Yeah.
All right. That's all, folks.
Thanks, everyone.
Yeah,
Thank you.
Thank you very
Yeah.
much.
Have a
Thank you
good weekend.
Thank you.
Thank you.
I'm gonna stop the recording here.
All right.